I know it's been 2 weeks since we went through these, right? But what do we have? We have a point and we have a slope. We need to find the equation in your slope-intercept form. So, what are we going to use? Well, the first thing we're going to use is we're going to use point-slope. And what's your point-slope formula? Y minus y1 equals m times x minus your x1. Okay, remember this? And this is your x1, and this is your y1 here. Now, we're going to plug our values in, and we're going to solve it for y, because that is your slope-intercept form. So plug your values in, and that's going to be y. Now watch out for double negatives. So that's going to be y minus a minus 5 equals 8/3 times x minus 4. So again, be very careful of the double negatives here. That's going to make that positive. And now we have y plus 5 equals, we'll distribute this 8/3 through, and that's going to be 8/3 x minus, how does this work? Well, that's a 4 over 1. 8 times 4, that's a minus 32. 3 times 1, that's a 3 there. Okay, is everyone all right with that so far? Now, we want to get this in slope-intercept form, and so the easiest way is to clear our fractions. So we're going to multiply this by 3. And if I multiply this by 3, bless you, then we get 3y plus 15 equals 8x minus 32. Now, what do we want the answer to be in? All right, we have 2 ways of writing our answer: slope-intercept form or standard form. So we want slope-intercept form, so that means we need to solve for what variable? We need to solve it for y. So we're going to move that 15x over. And now we've got 3y equals, we'll put that 32 and the 15 together, it should be 47. So that's going to be 8x minus that 47 there. We'll divide by our 3 everywhere. And then what's my final answer? In slope-intercept form, well, it is now y equals 8/3 x minus 47 over 3. Okay. Is everyone all right with how we did that? I know it's been a bit. But we're going over it again. Question 5. Similar. But this one talks about parallel lines. So we want to find our line equation that is parallel to 2x plus 7y equals 65. And it has to go through through 8, 4 here. Okay, so how does this one work? Well, we need to make sure that we get a slope. Okay, we need a slope somehow. Either we find it by solving for y, we find it by using the 2 points and calculating the slope, or they give it to us. But we have to get the slope. So in this case, this one has a line equation, and we want it to be parallel. So what does parallel mean? Parallel, remember, means they have the same slope. So let's take our equation, and let's solve our equation for y. And that is then 2x plus 7y equals 65. We'll move that 2x over. So 7y equals a minus 2x plus 65. Divide by our 7. And that leaves us now with y equals minus 2/7 x. And then we've got 65 over 7 there. So what we need is our slope. And what's our slope? Our slope is minus 2/7. Now, is that what we're going to be using? Yes. Why is it what we're going to be using? Well, it's parallel. And what does parallel mean? Parallel means we use the same slope, so we don't change it. Now, if it was perpendicular, we would be using a positive 7 over 2. But this one is parallel, so we keep the same slope. So now we have a slope that we're going to be using, and we also have that point way up here, which was 8, 4. So now we have everything that we need to use our point slope formula. So now we have our point, which is 8, 4, and we have a slope of minus 2/7, and we're going to use point slope. So that's what we're going to be using. So we found our slope. We have that original point, and we're going to use our point slope formula. And what does our point slope formula look like? Y minus y1 equals m times x minus x1. This is your x1, and that is your y1. Bless you. Fill in the pieces. So that's y minus 4 equals a minus 2/7 times x minus 8. I'll slow down a bit so you can get caught up here. So let's review what we did. It doesn't matter what we start with. We need to eventually get a point and a slope. Now, you can be given that slope. You can either take your equation and solve it for y. Find your slope. If it's the same, it's parallel. Negative reciprocal would be perpendicular. You can find it that way. Or with the next one, you'll be given 2 points, and you'll have to calculate the slope. But either way, you've got to have a point and a slope. So that's what we've got. So we used our point slope formula. And now we're going to distribute through. And we've got y minus 4 equals now minus 2/7 x. Negative and negative makes it positive. 2 times 8 is 16/7. We want this in slope-intercept form. So to get this in slope-intercept form, we're going to have to multiply it by 7. That'll clear your fractions. And that leaves me now with 7y minus, 7 times 4 is 28, equals a minus 2x plus 16. We'll add our 28 over. And that leaves me now with 7y equals a minus 2x, right? And 16 plus 28, that's a 44. Divide by our 7, and we are now done. So what does that leave me with? Well, that leaves me with now y equals a minus 2/7 x plus 44 over 7. So that one, we had to find the slope by taking our equation and solving it for y. Then we use the point slope formula. All of these require eventually using the point slope formula. Now, I am going to work out one of these applications for you. And so I'm going to now look at question number 9. question number 9. Now, we need to come up with our equation. And I made this one multiple choice just so you would know if you were on the right track or not. A biologist recorded 6 snakes on 16 acres in one area and 15 snakes on 33 acres in another area. Find the linear equation that models the number of snakes in X acres. So let's take a moment to think about what's going to happen here. What happens as I increase the land area? As I have more acreage, what happens to the number of snakes? We get more, right? So our slope had better be positive. Now, when we read this, we can't eliminate any of these yet because they're all positive slopes. But when we read this, the last part there says X acres. So X is going to be the acres, Y is going to be the snakes. So when we come up with our ordered pairs, we have to make sure that we put these in the correct order. So this is your X, this is your acres, Y is the snakes. So acres and snakes there. Let's come up with our ordered pairs. So we've got 6 snakes on 16 acres of land. So that's 16, comma, 6 snakes. And we also have 15 snakes on 33 acres. So 33, that's your acres. 15 is the number of snakes. Is everyone all right with that so far? Now, what do we need to do? We need to come up with our slope. So, we can either take an equation if we have one and solve it for y to get the slope. We don't have an equation though. What do we have? 2 points. Okay, so how do we find the slope with 2 points? I know we've done this before. What's the formula for the slope here? The formula for the slope is m equals y1 minus y2 over x1 minus your x2. So there's x1, y1, x2, and y2. So we'll plug it in. And what does that give you? That gives you 6 minus 15 over 16 minus 33. So breaking that down, 6 minus that 15, that's going to be a negative 9. And 16 minus 33, that's a minus 17. Double negative makes it then what? Positive. This is my slope. This is your m. Let's use process of elimination to get rid of some answer choices here. My slope is 9 over 16. So which ones can I eliminate? My slope is 9 over 17. So which ones can I eliminate? This one's got 9 over 17. 9 over 17. What about C? C has a slope of what? 1, right? So C can be eliminated. What about D? D is 17 over 9. So that one also can be what? Eliminated. So now, just by finding the slope, we've got it down to these 2. And always do that whenever you have a multiple choice question. Doesn't matter what class it's for, always try to use the process of elimination. Because if I don't know what I'm doing and I have to guess, I've now got it down to 2 possible choices instead of 4. So every time you do a step, mark out which ones don't work. So now we know it has to be either A or it has to be B. How do we finish it? All right, well, here is my slope, which is 9 over 17. Now we can use point slope. And we can use our point slope formula, and that is y minus y1 equals m times x minus your x1. We've got our slope, which is here. We're going to use either point. It doesn't matter. How about the 16 comma the 6 there? This is going to be my x1 and your y. Plug it in. And that gives you now y minus 6 equals 9 over 17 times x minus 16. And we eventually will come up with one of these answers. We know it has to either be A or B. That's it. We've got all the others eliminated, so it has to be one of those two. If it's not, we know we made a mistake. Distribute that 9 over 17 through. And that leaves you with y minus 6 equals 9 over 17x minus, we've got 9 times the 16 here. That's going to be a minus 144 over 17. Clear out the fractions by multiplying it by 17. It's going to clear all those fractions out. We now have 17y minus, we've got 17 times 6, that's 102, equals 9x minus 144. And what do we want to do? We want to get this in slope-intercept form. So we're going to go ahead and add this 102 over. Now we've got 17y equals 9x minus, is that going to be 42, isn't it? We've got 144 minus that 102. That should be a 42. And how do we finish it? We divide it by 17. And that gives you y equals now 9 over 17x minus 42 over 17. And is that one of the solutions there? Yes, it is. So what's the answer going to be? It's going to be B. Okay, the answer should be part B. We worked it out. Right? We used process of elimination, and it looks like it's going to be that one. So always use process of elimination whenever you have a multiple choice question. Doesn't matter what the discipline is. Every time you do something or work out part of it, try to get it down to as many, as few choices as possible. Okay, well, if we don't have any others, then we will go ahead and start 2-6 and 2-7. And this is actually going to be easier. And this is going to require us to use common graphs from our textbook. So if you look in the back cover of your textbook, you're going to see these graphs. This is a very easy section. All you need to do is figure out what shape it is and then how it's moved. It's just like graphing a line, only instead of a line, we have a curve. So this is 2, 6, and 7. So we're going to look at 2, 6, and 7, and these have been combined together. Now, when we go to graph things, the first thing we do is we need to identify what the graph looks like. And so we're going to start off with an easier one. And let's graph f of x, or you can use a y, they're the same thing. How about we look at 2 times the absolute value of x plus 5. Okay, let's try to pay attention to this. So let's keep the side noise down a bit. This section, as long as you pay attention, is very easy. Now, first thing we do is we identify what operation we have. What are we doing to this x? That x has an absolute value on it, doesn't it? Okay, so let's go to the back cover of our textbook. And let's see what it should look like. It should look like this, right? Absolute value makes a v. And what I usually do is I like to just draw it over the side. So it should look like this. Some sort of v. Now, this 5 is on the end. That is like your y-intercept. It's a positive 5, so it makes it move up 5 units. And this 2, well, it's not your slope, but it's similar to the slope, because slope only applies to lines. And that's like a slope of 2. And we'll write that as a 2 over 1. So that means we go up 2 and we go over 1. Now, how do we graph this? Where do we start at? We're going to start up 5 units. And that's going to be right here at 0, 5. Is everyone okay with that? Right? Why did we move it up 5 units? Because this was a positive 5 on the end. Now, what does the graph need to look like? It needs to look like a V. So here's where we start at. All right, we're going to start at this 0, 5. Now, this is like your slope. And what do? We go up 2 units and over 1. So we went up 2 and over 1, and we made a new dot. Now, when I connect them together, it needs to make a V. So there's half of it, right? Up 2 and over 1. How do we get the other side? Well, it needs to look like that. So we go back to our starting point here, and we go up 2 and back 1 unit, and we make the dot over here. Right? Up 2, back 1. And why did I put it back over here? Because when I connect them together, what does my graph now look like? It looks like the V that it should. Okay? So you know what it's going to look like. And this number in the front, well, that tells you how wide it is, or narrow. So the smaller the number, what happens to it? The smaller number in front is going to make it look like this. Fractions are going to make it expand out and be a lot wider. Let's look at another one. Let's try to graph y equals, how about 3 square root of x minus 4. So the first thing I do is I need to figure out what is it going to look like. We go to the back cover of our textbook. This is a square root. So the square root looks like that. So the first thing I do is I identify the fact this is a square root, and so it needs to look like this. What is this minus 4 going to do? make it down. Move down 4 units. And what about this 3? 3 is like a 3 over 1. So when I go to graph it, where am I going to start at? Down 4 units. So we're going to start right here at 0, -4. What am I going to then do from that 0, -4? I'm going to go up 3 and over 1. So up 1, 2, 3, over 1 unit, right there. Curve it together. And there's your picture. As I went up 3 and over 1. So over 1 and up 3 units. And that's it. A lot of times, I think students try to make these more difficult than what they really need to be. They're not difficult as long as you follow the rules. Let's do another one. Let's do one with a negative in front. And we'll make this one a fraction. So the first thing we need to identify is the fact that this is an x squared. So we'll go to the back cover of our textbook here. And what does the x square function look like? The squaring function? Well, it looks like a u. So the first thing we do is we go back, figure out what it's going to look like. It looks like a u. Ours is going to be upside down. Why is ours going to be upside down? Well, it's going to be upside down because this is negative. So it's going to flip it over, right? It's like your slope. Think about your slope, okay? What happens with a positive slope? It goes up. What about a negative slope? It goes down. Same concept here. Positive slope makes a u up like this. Negative slope makes a u down like that. What does this 2 do? Well, that 2 is positive, so that's going to make it move up 2 units. Now, here's the only new part. This fraction must be over 1. So you have to make it over 1. So it's minus 1/4 over 1. And that minus is going to make it go down. So all fractions have to be over 1. Otherwise, the graph won't look right. So always make sure if it's a fraction, it's over 1. If it's a whole number, it's fine. But if it's a fraction, you've got to put it over 1. Where are we going to start at? We're going to start 2 units up. That's going to be at 0, 2. Now, what are we going to do? And I know these are kind of hard to draw, but we're going to go down about a quarter, so just down a little bit, over 1. Okay, down about a quarter, over 1. There we go, on that side. How do we get the other side? Down about a quarter, over about 1. Curve it. There's your picture. Now, why is it so wide? Why is it wide like this and not narrow like this? Well, it's a fraction. Anytime you have a fraction, it's going to make it wider. Right? Whole numbers make it smaller, make it more narrow. Why is it upside down? Well, it's upside down because it was a negative in front. Now let's review what we've done before, and now we're going to be moving it left and right. So let's do a little bit of review, and then we'll add on how to move it left and right. So when we go to graph, step number 1, the number in front is like the slope. Okay, so it's going to be similar to the slope. It must be over 1. So if it's not over 1, you're going to have to make it over 1, like we just did. We also learned about numbers on the end. So numbers on the end of that expression, okay, numbers on the end, if they are positive, they move it up. If they are negative, they move it down. The new part that we're going to talk about right now is numbers under the root in the parentheses. Those move it left and right, and they're opposite of what you think they would do. So if they're under the root or in the parentheses, then if they are positive, they move it back to the left. Negative values move it to the right. Opposite of what you think it should do. Right? Because you would think positive would move it to the right, negative would move it to the left, but it's the opposite. Because you're actually setting them to 0. Now we're going to graph a couple of these where we have all the steps involved. And it can be f of x or y, it doesn't matter. So this one has lots of different translations. Translations are just how we move it. Left and right, up and down. Those are translations. So first off, what should my picture look like? Well, what is my power on the parentheses? It's a cube. So we need to go back to our textbook. And we look at the cube here. And it's a cube function, so it's going to resemble that. So I, again, always like to draw the cube function, or whatever function it is, over here. And so we know it's going to eventually look something like that. Okay? It needs to look like this. This just sets up our pattern. Now, what's going to happen? I always like to start at the end and move my way forward. So the negative here, it's a -4. That moves it down. This 2 is inside the parentheses. It's inside the parentheses or underneath that root. And that is positive. So that's going to force it back to the left. And then what about this -3? Well, that -3 is going to be a -3 over 1. So we're going to move down 3 and over 1. Is everyone okay with that so far? Now, where are we going to start at? Let's label the ordered pair. Where are we going to start at? Okay, this is moving it back. Okay, moving it back to the left, 2 units. So we're going to start at -2, and we're going to have to move it down 4. So we're going to start at -2, -4. Is everyone okay with that? Right? Follow the arrows. Down, back. We know that the graph needs to look like what? That. Okay. So where do we start at? -2, -4. So that is back 2 units and down 1, 2, 3, 4 units. And what am I going to now do from here? Look at my slope. Down 3 over 1. So this is where I start. I'm going to go down 1, 2, 3, and over 1, down 3, over about 1. Curve it. Now, how do I get the other side? I go back to my starting point here. I go up 1, 2, 3 units and over 1. So that's going to make my other dot right about there. And there is your picture. Now, why is it the opposite of this one? Notice this one goes up from left to right, doesn't it? What does this one do? Down from left to right. Why is it going down instead of going up? Because the 3 in front was what? Negative. Okay? So that's why it looks like this and not like that. Let's do some more of these. We'll do a couple more, and then I will give you a graph, and you're going to have to tell me the equation that it came from. We'll do a couple more of these. So let's try to graph this one. Be careful with the roots. It's not a square root, it's a cube root. So again, what do? We go to the back cover of our textbook. What does it look like? Looks like that, doesn't it? So that is the picture that we need. It needs to look like this. And I always like to start on the end. So this 5 moves it up. This -1 moves it forward. And this 1/3 has to be written over 1. So then it's -1/3 over 1. You have to make it over 1, otherwise your graph will be distorted. So where are we going to start at? Forward 1, switch our sign, so that's going to be at 1 and 5. So we're going to begin our graph at 1, 5. Okay, so we're going to start here at about 1, 5. Now ours is going to look like this. Why is ours going to look like this instead of like this? Ours will look like that because ours is what? Negative here. So we're going to go down about 1/3 and over about 1. So down about 1/3, over about 1. You got graph paper, so it'll be a little bit easier. But just go down about 1/3, as close as you can get it, over about 1. There's that piece. Now, how do we get the other side? We know it needs to look like this. Ours is going to look like this, though, right? Because ours is negative. We go back to our starting point, which is right here. It needs to look like this. So, instead of going down 1/3, we do what? We go up about 1/3 and over about 1. And we can connect them together. And there is my new graph. Now, I'm going to give you a picture, and you're going to have to tell me which one of these you think the graph came from. Okay, so I'm going to give you some choices. You're going to tell me which one you think it came from. So here's some choices. And let's say I give you y equals, how about positive 3x minus 1 squared plus 3. Let's see if it's this one. How about we use a minus 3 square root of x plus 1 minus 3. So there's another choice. Okay, let's come up with another square here. How about y equals 1/5 x minus 2 quantity squared plus 4. And let's do one more. How about y equals a minus 3 times x minus 1 quantity squared plus 3. Okay, so which one can I eliminate at the very beginning? Yep, square root, right? Why can I eliminate the square root? Because what does the graph have in it? It's a U. And if it's a U, that means it has to look like this, doesn't it? Ours looks like that. So obviously we can get rid of B. Now, which others can I eliminate? Look at the shape of the graph. I can eliminate answer A. Why can I eliminate answer A? Positive. What about C? Can I eliminate answer C? Yes. Why? Because it's 1/5, right? It's still positive. Because this would look like this. Now, why is D the correct choice? Well, let's see. This 3 on the end would move it up, which it does, right? Right there's 3. This minus 1 here, what does that do? Forward, which makes it right there. And this is making it go down. So do you see how I was able to identify which one it was from the picture? Let's do one more. We'll do a square root graph. So here's the picture. And here's some choices. So it's giving you choices here. You'll be able to figure out which one it is shortly. So that's supposed to be up one over once here. So let's see. Here's your last choice. And let's see which one it is. So I've got 4 choices. we know they're all square root graphs. Which one of these can I eliminate? Okay, I can eliminate choice C. Why? Yep, because it's negative, and that would look like this. See, it would be upside down, wouldn't it? This negative is going to make it upside down. Okay, so which other one can I eliminate? I would say I can eliminate A. Now, there's a couple of reasons why I can eliminate A. Well, let's look at this 8 in front. That 8 in front would be up 8 units and over 1 unit. So I'd have to basically go clear up here and over 1. And that would look like that. Also, this one, it doesn't move down any, does it? Right? So this one would be just here. And we don't start there. Okay, we start down here. So A can be eliminated. Do you think it's B or D now? Which one and why? Yeah, I'm going to say it's going to be answer D because that makes it go down. This one makes it go up. So we now know that it has to be answer what? D. And there are a couple of these in your homework. So I did give you a couple of those. We've got a little bit of time left. We're now going to talk about the greatest integer function, which is a little bit different. The greatest integer function is a case of stairs. And let me see how we're doing on time here. Okay, so we're going to go ahead now and talk about the greatest integer function. And these are called greatest integer bars. And if you need to leave early for practice, make sure you sign the sign-in sheet over there. And these are called greatest integer bars. And what they do is they make it round down. So the greatest integer bars, they make it round down. There's also the least integer bars. Greatest integer bars are also sometimes called the floor. Our textbook doesn't use floor, but other textbooks do. Greatest integer bars are also called the floor. Least integer bars are called the ceiling. And what they do is they round down. So just so you understand what I mean by that, let's look at a couple of these. We're going to find the greatest integer of these. And these are the greatest integer bars, and I'll give you a couple of these to work through. We'll talk about what these are and how they work. And all these are going to make you do is round down. Okay, so the greatest integer makes it round down. So 5.2, that's going to make it go down to 5. 3.7, it has to go down to the next integer, so 3.7 would go down to what? 3. 0.2 would go down to 0. What about a minus 1.2? Watch your signs here and think about what you have. Minus 1.2 would go down to minus 2. Right? You're going down to the next integer. What about a minus 2.5? Well, a minus 2.5 would go down to a minus 3. Okay? It's going down. And think about negatives are over here, so you have to go down to the next one. What does the graph of the greatest integer function look like? Well, the greatest integer function graph looks like a case of stairs. And what we have to be very careful of is whether we have an open circle or a closed circle. And this is also in the back cover of your textbook, but I'm going to write it up here and make it bigger so we can make sure we understand what the picture looks like. This one's a little bit tricky. I'm going to draw us up a picture here. Because you need to make sure you know about the open and the closed circles. So here's our picture. Now this is the same as what you're going to see in the back cover of your textbook, right? Okay, it's the same thing. Right down there. Very, very important. You always start with a closed circle. So we always must begin with a closed circle. So let's graph a couple of these. Using this again as our kind of guide here. So what is this one going to look like? Well, first off, we have the greatest integer bar, so make sure you know that's the greatest integer bar, not an absolute value. So we know that it needs to look like a case of stairs. This minus 3 is on the end, so that's going to force it down 3 units, isn't it? Is there a number inside to make it go left or right? No. So it's not going to move left or right any. It's just going to go down 3. And what about this 3 here? Well, that's a 3 over 1. So up 3 and over 1. So where are we going to now start at? We're not moving it left or right any, so we're going to start at 0, negative 3. And wherever we start with a closed circle. That's the most important part. Wherever you start, you have a closed circle. Is everyone okay with that? Now, what does it need to look like? It needs to look like a case of stairs. And so the way I do this is I just go up and over, and then I draw my dots. And then we fill it in after we're done here. So, starting here, we go up what? 3 over 1. Make a circle. Up 3 over 1. Make a circle. Up 3 over 1. Make a circle. And if you want to do a couple in the down direction, you could do that too. Down 3, back 1, make a circle. Now, what does it need to look like? Okay, let's look. It needs to look like this. Okay. What's ours going to look like? It's going to look similar. Okay, but look, when we draw this, let me use a different color here so it's easier to see. Notice the closed circles are below. So it's going to look just like this. And there's your graph. So what did that 3 do to it? That 3, normally it's like this. Okay, normally it's like 1 tall. But what did that 3 make it do? 3 tall. So it made it 3 times as tall. That's all it did. And then what did we do? Slid it down 3 units. Let's do another one. And then we'll look at our homework. So one more. And then we'll talk about our homework here. Now, if it's negative, what do you think the graph is going to look like? Well, instead of going up the stairs, it's going to do what? It's going to go down, isn't it? And so let's look at graphing a minus 1/2 times the greatest integer of x. I'm not going to put anything else here. We'll just look at minus 1/2 the greatest integer of x. Can anyone tell me where I'm going to start at? We've done a lot of these. We're going to start at what? 0, 0. Okay? And I picked this one on purpose so you would remember. There's nothing here, nothing inside. So we're going to start at 0, 0, and you have to have a closed circle. Very, very important on these as well, that when you look at that minus 1/2, that's going to be minus 1/2 over 1. It must be over 1. So it has to be over 1. So you always go forward 1 unit. Now we know that our case of stairs should be going down. So we're going to start here at 0, 0 with a closed circle. And then what are we going to do? We're going to go down about 1/2 and over about 1. Make a closed circle. Down about 1/2, over about 1. Make a closed circle. Okay. And I know it's hard to see. You got graph paper, so yours will be a little bit easier. Down about 1/2, over about 1. So look what happens here. You just fill them in, just like this. It needs to look like a case of stairs. Now, if you want, you can add a few in the opposite directions as well, because you can go up here, you can go up about 1/2, over about 1. Up about 1/2, over about 1. And there is your graph. So, what happened to my case of stairs? Instead of going up from left to right with the closed circles, what am I doing? Down. Okay, so this is now going down from left to right instead of going up. Also, instead of it being at 1, it's at what? 1/2, because it's a 1/2 as tall. It's the same 1 across. Always has to be 1 across, but it's going down from left to right. Always go over 1. So let's talk about our homework quickly here. See what we went over. Okay, we did do 2-6 and 2-7. But we didn't finish all of it. What you still have left to look at, and we'll cover next time, is 12 through 15. So you should be able to do, for your homework, out of 2-6 and 2-7, you should be able to do 1 through 11. So try 1 through 11. And then I will see everyone on Thursday. And we'll finish up this section. And we'll look at 2-8 as well.